This is Algebra 1, Semester 2. It's the third unit called Quadratics. It's the 8th lesson in that unit called Graphing A, x squared plus bx plus c practice. It's on CreatorMathcom, or you might have to put in CreatorMath.weebly.com, and it's under the Algebra tab. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages. So remember, there's notes that go with all of these problem sets. You're going to copy those into the right pages from CreatorMath.com under the, don't forget the Algebra tab. And I'm tempted just to show you this really quickly. Right, if you're on CreatorMath.weebly.com, and you might be able to Google just straight CreatorMath.com, or you might have to Google CreatorMath.weebly.com. Make sure here's what the home page looks like. Right? You're clicking Algebra. You're scrolling past the vocabulary, and you're on Semester 2. All of this stuff, by the way, the table of contents goes on pages 2 through 6 of your comp book, but you're copying in every line all the way down. And notice that each one of these is a unit. There's modeling 2 variable data. There's quadratics. We are on the 8th lesson. So let's go down to number 8 right here. Graphing ax squared plus bx plus c. It goes on pages 69 and 70 of your comp book. Here are the notes. And it does take a second to update, and sometimes I even have to reload it twice for mine. See how it's kind of staying kind of blurry right there? So when I expand it, it bounces back. It's not loaded yet. And I can tell you there's times myself when I have to go back and reload this. 6970, here we go. There we go. I saw it sort of flash. Did you see that? Now I'm able to expand it and see all the notes right, because it's a good resolution picture. So this is just talking about graphing parabolas. Parabola is the graph of a quadratic. A quadratic is anything raised to the power 2. And there are 4 key points we're looking at when graphing a parabola. We're looking at the roots. Where does the parabola cross the x-axis, also known as x-intercepts, roots, and zeros? Right? 3 names that I know of. There might be a couple more names that I don't know of. You're also looking at the vertex. We're going to skip that in this lesson. We're going to focus on the y-intercept. Where does the graph cross across the vertical axis or y-axis? So we're going to look at the 1, 2, 3 points, critical points here. We're going to ignore vertex for now and do that in a different lesson. A little bit easier to focus on that separately. So let's get into the first problem. We'll spend a little bit of time on it using Desmoscom. So we're also going to go to I'm also pulling up Desmos.com here. And we're going to type in the first function. In fact, let's go ahead and do that now. It tells us to type this in. So here's the first function, f of x equals, and you can type in each one. I'm going to type in this first one because I know it's the right one right off the bat. It's minus 9. Wait, clear that out. We need f parentheses x equals. Now we're going to type in negative 9x. And we're going to square it. Notice it's already showing us a parabola. It's already showing us upside down, right? This should tell us something right off the bat. Let's do minus 60x. There's more. That changes the shape of the parabola a little bit. Minus 36. All right, so we're going to plug in these answers, right? And then we're going to look at the graph they gave us, and we're going to match them up. That's all this assignment is for. The 4 points they give us on this thing is a vertex we're going to ignore for now, but see how the graph comes down and crosses the y-axis here. It crosses the x-axis here and here. And this is a little hard to see, I got to admit. If I had to look at these grid lines, it looks like there's a grid line here and here. That's hard to see. You're going to see it better when you look at the actual assignment. But if I'm looking at what my roots are, right? Roots, or where are these x-intercepts? And I click on this, there's one at negative 6, 0. So yeah, this does look like a line here. This could be negative 6, 0. And there's one over here at, ooh, look at that. Looks kind of yucky, right? Negative 0.667 comma 0, right? And that looks like it is a little bit to the left of the y-axis here. So I like that for the moment. How about the y-intercept here? The y-intercept is going to be negative 36, and here we are way down here at about negative 36. So I like this a lot. I'm pretty sure this is it, but let's focus on a little bit more information here, right? First of all, the negative here and here tells us that this parabola is opening upside down, right? So a normal parabola goes like this one goes like this, then it's made narrower because of the different components inside the other terms of the quadratic. Also, let's look at roots a little bit closer. So yeah, we see this root here at negative 6, 0, and that sure enough looks like what they're graphing. Where does that come from? Well, we have an x plus 6, and remember the 0 multiplication rule. Why am I saying that wrong? 0 product rule. There we go. I think that's more acceptable. If this is x plus 6, then this has to go to 0, this has to go to 0, and this has to go to 0 for the whole thing to equal 0. Why does it need to equal 0? Because y is equal to 0 at that point, right, where it crosses. So to find out where the x-intercepts are, we put y equals to 0, which means f of x would be equal to 0 here. So the whole thing equal to 0. Each of these components must be 0 itself to produce, or one of them, or all of them. So we test both cases. So let's take x plus 6 and put it equal to 0. And we subtract 6 from both sides, and we get x equals minus 6. So that checks out with this root right here and here. I like that a lot. This one's a little bit even more interesting here, this 0.667, and it's negative. Let's take the other one here. It says 3x plus 2, and put that equal to 0. Let's subtract 2 from both sides. 3x equals minus 2. Divide both sides by 3, and look at that. Minus 2/3. That's beautiful. So they're going to tell me that in decimal form, minus 0.667, right? But that's a minus 2/3, and that again checks out for exactly where that's crossing x equal to this number. That's where it's crossing that. And then we're going to do it on this one, but not on the others. But how do we know that this 36 is the y-intercept? Because the x values are 0 here. So if all the x values were 0, we would say f of this 0 goes in here, would produce a 0 here, would produce a 0 here, and we'd be left with minus 36. So we know that the y-intercept is going to be at minus 36 right here, and that checks out too. So now let's see if we can pick up the speed a little bit. And just look at this graph. Looks like we have, if this says 2, this is interesting. If this says 2, this must be what? 1, 2, 3, 4. So this must be 0.25, 0.5. This is just beyond 0.5 if I'm reading this right. No, we went to 1. I'm sorry. So here we are at 1. There would be 1.5. Looks like 1.25, right, is one of our roots. And back here on this one, I can't totally see the grid lines here. If this is a quarter, no, this is a half and almost 1. So let's look at, how about, is this simpler? How about the y-intercept? Minus 14, minus 16, so minus 15. So I'm just going to go with that number. Look, I already got this because this is minus 15. It's the only one in the whole bunch. This is out. It would be minus 36. This is out. It would be minus 5. So I already know my answer. Let's look at those roots a little bit closer. 4x minus 5 equals 0. And let's solve for x plus 5 on each side. 4x equals 5 divided by 4 on x equals 5/4. So that means 1 and 1/4. Right? So that looks just right here. Now I am happier with that. This is 0.5, 1, and this would be 1.5, so 1.25 is right in the middle. So check. I like this. Let's check the other one. 4x plus 3. 4x plus 3 equals 0, minus 3, gone. 4x equals minus 3, divide by 4 on both sides, x equals minus 3/4. So it does look like there's a faint grid line here, and I really wish this was printed better. That would help us a little bit. Looks like there's a faint grid line there. And is this at 0.75? I guess if I could see my grid line, I might know, right? That should be at minus 3/4, right? So minus 0.75 right there. I think it looks pretty good, and given this, this one is, I'm selecting this first one, all right? So there's a prior lesson where we identify these same 3 critical points of the parabola. It was a lot easier because they didn't have this lead term. They didn't have a term out here in front of the x squared. So this one's ax squared minus bx plus bx plus c format of the standard form of the equation. This number up front starts to make this a little bit more complicated. So when we're finding roots, we're doing a little bit more investigation. Let's just do the y-intercept looks the easiest first. This is minus 4, minus 6, so this is going to be minus 5. So give me something with a minus 5. I already know the answer right there. And here we're just solving this, and I'm going to do this one. Let's just move the 5 to the other side of the equation. So this is going to be x equals 5/4. That's the same thing we got on the last one. And let's move the 1 over to be negative 1 over 5. X equals negative 1 over 5. I'm solving these simple 2-step equations in my mind and getting a negative 1/5 and a positive 1.25. Here's, that's 1 and 1.25. Check. Here's a line here. I can see that. And this is minus 1/5, 20%. So here's the whole 1. Here's half of 1. And it's not quite in the middle, it's a little bit back. I'm going to say that's 20% right there, all right? But we could draw it back out on Desmos, which is where this graph came from in the first place. But let's keep moving. So we're going to go with that first one. Notice in this case, the y-intercepts have been by far the easiest to help us narrow in on. Now, they could have made the problem set a lot more difficult by making everything like, see how this is plus 3? There's only one of them with a plus 3. So if this is crossing at plus 3, check. That's the y-intercept. I already know it's this answer. Most teachers are going to be a little bit more coy and not just give you all of these so varied answers. They're going to make them all plus 3 down here, right? You're going to have to investigate all 3 points to find out which one of these parabolas is the right graph of that function. Well, let's go ahead and do this. If this is x plus 3, we know that one of our roots is going to be at x equals minus 3. So do we have that? Here's 0, minus 1, 2, 3, so that's good. Now I'm pretty sure this is the right answer. I'm going to do this one in my mind. I'm going to say 2x plus 1. I'm going to move the 1 to the right side of the equation, so it's going to be negative 1 and divided by 2. X equals negative 1/2. And this looks exactly right here. Here's negative 1 and 0, so negative 1/2, so check. So it's definitely this answer here. Which one of my choices? Well, what's this? 15 and 20, 15, 16, 17, 18. Haha, anything with a plus 18 is going to be a candidate. Look at them. They gave us 2 here, right? Finally, they're getting a little bit better at us. This is a minus 18, so it's out. This is a minus 49, so it's out. So it's one of these. This is interesting to us. We have x plus 3 squared. So let's look at this point here. This is 0. And this is the x-axis right here, you guys. So this thing is touching right here at minus 3. Whichever one has a root of minus 3. So does this have the root of minus 3 or this one? Well, you got to remember, because of the zero multiple property, you're going to have to, multiplication property, you're going to have to take x plus 3 and put it equal to 0, right? That switches the sign of that number. X equals minus 3. So sure enough, it is this one. And we've proven it. This one would have a root at x plus 3. That's where its root would be, or x-intercept. All right, I see a y. Oh, you know what? Look at this. This is at plus 3 now. I see exactly what they did. And this is up at 18. So it's the one with 18 and the root of plus 3. The root of plus 3 always reverses because you have to put it equal to 0. So it's x minus 3 here. This is the right one. That's going to produce a root of plus 3. And this is the one with 18. That's where it's going to cross over or intersect with the y-axis. They used the two similar equations, right, functions, and graphed both and then put them back to back for us. So they're really leading us through this in a gentle way is what I would say. I hope you see it that way too. So here's a root, 1, 2, 3, 4, 5. This is 3. You got a plus 3, and 1, 2, 3, and a minus 3. So that's going to be good. And we're crossing or intersecting the y-axis at negative 15, 16, 17, 18, 19, 20. So this is minus 18. So anything with a minus 18, here it is, and an x plus 3 and an x minus 3. And what I meant was x plus 3, x minus 3, which reversed to be x equals negative 3 and x equals positive 3 when we put them equal to 0 and solve. And that's our two roots there and there. Not sure about the scale here. If this is 10, 2, 4, 6, 8, 10. So each of these, I see a line here. I see a grid line here. This is 2, 4. So this is 3 point something here, right? Plus minus 3 point something. And we're intersecting the y-axis at negative 50. No, this is 40. This is 50. So how about 49? Yeah, I see a negative 49 right here because of this. And it looks like we're only going to need to solve one of these, right? 2x minus 7. We're always putting it equal to 0. So plus 7, plus 7, and gone. And 2x equals 7 divided by 2, divided by 2. X equals 7 halves. Woo! Or x equals, it goes into there 3 times, right? 3 times 2 is 6, and there's 1 left over, so 1 and a half. Let's see, is it 3 and a half? This is 2. This is 3 and a half. I'm okay with that. So a positive 3 and a half and a negative 3 and a half, because each of these would reverse once we solve them. You'd get one positive 3 and a half, the other negative 3 and a half. Okay with that? Wow, this is hard to see. I can barely see, but look how big this number is. 500 and 600. 530, 540. There we go. Guessing pretty good. And there's nothing else even remotely close to that. So this is my right answer. The roots, and I'm glad they're making it simple because I can't really see the roots here. I don't even know what the scale is on this. But it makes sense that possibly it's going to be x is equal to 9 and x is equal to negative 10 for the roots. Where's the y-intercept? So here's the parabola coming up, and here it is crossing. Here it is crossing the y-axis right here, right? So this looks like negative 20, negative 30, negative 40, negative 35 maybe? All right, negative 32. That's my only option that's even close. How about the roots? It looks like it had have a root at 8 and a root at negative 1/2. I see a grid line there and there. So yeah, that looks like a root at 8. Sorry, I blocked it. There's a grid line here and a grid line here. This looks like, right, we're about 8 on here. And a minus 1/2. So this looks very close to the x-axis here. I would just believe that, yeah, that's probably the right one there. And because the graphs are sort of so poorly laid out for us in this one, I appreciate that, you know, the answer choices they give us are so far apart. It's not even close. So it's a little bit, they're being vague in one way, but then they're sort of making up in the other way for us to solve this. Here's a y-intercept at negative 5. Which one has a negative 5? I know it's this one. Let's just check the roots. This would be x equal to 1/2, and this would be x equal to negative 5/4. x equal to 1/2, right? This is 1, this is 1/2, that's good. And negative 5/4 means negative 1 and 1/4. So this is 1/4 of the way on down to negative 2. So this one checks out also. I've matched up the y-intercept and the two roots. That looks like my y-intercept, negative 15. All I got to do is find the one with negative 15, and I got it. So I know it's this one. Let's check roots. X is going to be equal to 5 here, and x is going to be equal to negative 3/5. So do I have a root at 5? Yep, that's a 5 right under that line right there. That's 5. And do I have a negative 3/5? Looks pretty good. I mean, I'm estimating, I'm guessing. All right, if this is 1, 2, 3, 4, 5, then 1's here, 3/5. I'm guessing, but it looks pretty good. Y-intercept right here. This is minus 25, minus 20, 2, 4, 6, 8, 10. No, so 1, 2, 3, 4, 5. So how about minus 21? Anything with a minus 21? Not a plus 32, not a minus 5, not a minus 15. So I know this is it. Check the roots. This is going to be x equal to 3/5. Right? And this is going to be x equal to a negative 7/5. So 3/5. This is 5. This is 1. So 3/5 here. Pretty good. I believe that. And negative 7/5 is negative 1 and 2/5. So here's negative 1 and 2/5. I believe that. Check, check. So I'm going to go with this answer as this is it. All right, here's my y-intercept. Where are we? We're at 30 and 35. So this is a plus 32. Let's focus in on that. Plus 32. Let's check the roots. This root's going to be x equals negative 4/3. This is going to be x equals positive 2/3. So can I see enough? Here it is right here. This is 5, so this has to be 1. I have a positive 2/3. Yeah, it's about positive 2/3. Again, I'm guessing, but it's pretty darn close. And given the others, how far off they are, right, and this whole issue, I know this is the right one. Negative 4/3. Here's the grid line here, and it's going 1/3 further into the negative. I believe that too. So I like that one. So that wraps up this one. It's Algebra 1, Semester 2. It's the 3rd unit Quadratics. It's the 8th lesson, graphing a x squared. And a is when you have a number in front of the x squared, plus bx, and then we had numbers in front of that, plus c, right? It's on CreatorMath.com. You might have to put in CreatorMath.weebly.com under the Algebra tab.